Hello students, welcome to my channel Maths with VTC. Today we are going to see quadratic equations. Already we studied quadratic polynomial. Then what is a quadratic equation? If a quadratic polynomial is equated to 0, then it becomes a quadratic equation. Why should we study quadratic equations? Like a pair of linear equations, quadratic equations also sometimes represent real life problems. So to solve such a real life problem, we have to solve the corresponding quadratic equation. So first let us see the general form of a quadratic equation. So a quadratic polynomial is ax squared plus bx plus c. If it is equated to 0, we get ax squared plus bx plus c equal to 0. Here the condition is a not equal to 0, because if a is equal to 0, it is no longer a quadratic equation. Okay. So here are some examples. X square minus 5x plus 1 equal to 0. 3x square plus 1 equal to 0. X plus 3 into x minus 5 equal to 0 are some examples of quadratic equations. Now let us see how a quadratic equation will represent real life situations. Let us see an example. Suppose a charity trust decides to build a prayer hall having a carpet area of 300 square meters with its length 1 meter more than twice its breadth. What should be the length and breadth of the hall? Remember, we are not interested in the answer of this problem. We are interested only to represent this problem mathematically. Suppose the breadth of the hall is x meters, then its length should be 2x plus 1 meters, because it is given. Length is 1 meter more than twice of its breadth. So twice of its breadth is 2x. 1 meter more means 2x plus 1. Therefore, length should be 2x plus 1. Consider the diagram given here. So I have taken breadth as x, then length is 2x plus 1. We know the formula for a rectangle. Breadth into length is equal to area of the rectangle. Therefore, area of the hall is equal to 2x plus 1 into x, which is equal to 2x square plus x. We are given it is 300. Therefore, 2x square plus x is equal to 300, or 2x square plus x minus 300 is equal to 0. So the problem is represented as a quadratic equation. Here x represents the breadth of the hall, and the corresponding problem is converted to a quadratic equation. 2x square plus x minus 300 is equal to 0. If we solve this quadratic equation, we will get the required breadth and length. Okay. So the general form of a quadratic equation, you remember ax squared plus bx plus c equal to 0. Here a not equal to 0. Now one more situation. John and Jeevanti together have 45 marbles. Both of them lost 5 marbles each. And the product of the number of marbles they now have is 124. We would like to find out how many marbles they had to start with. So here also we are not interested in the answer of this problem. We are interested only to construct the corresponding quadratic equation. Okay. So we are given John and Jeevanti together have 45 marbles. So you take x be the number of marbles John had. Then automatically Jeevanti will have 45 minus x, because the total of marbles is equal to 45. So if John had 45, Jeevanti would have 45 minus x. Both of them lost 5 marbles. Therefore, John will have x minus 5 marbles, and Jeevanti will have 45 minus x minus 5, which is equal to 40 minus x. So at present, after losing the marbles, they have x minus 5 and 40 minus x respectively. Now their product is x minus 5 into 40 minus x, which is equal to 40x minus x square minus 200 plus 5x, which is minus x square plus 45x minus 200. We are given this product is equal to 124. So equate this polynomial expression to 124. Then we get minus x square plus 45x minus 324 is equal to 0. which is a quadratic equation. Therefore, the number of marbles John had satisfies the quadratic equation x square minus 45x plus 324 is equal to 0. Next, a cottage industry produces a certain number of toys in a day. The cost of production of each toy in rupees was found to be 55 minus the number of toys produced in a day. On a particular day, the total cost of production was rupees 750. We would like to find out the number of toys produced on that day. You read the problem carefully. We have to construct a mathematical model representing this situation. A cottage industry produces toys. The cost of production of each toy was found to be 55 minus the number of toys produced in a day. So on a particular day, the total cost of production was rupees 750. We would like to find out the number of toys produced on that day. So what is to be found? The number of toys produced. So we take X is the number of toys produced on a particular day. So we take X be the number of toys produced on that particular day. Therefore, the cost of production of each toy is equal to 55 minus X because we are given like that. Now, the total cost is equal to X into 55 minus X because X is the number of toys produced and 55 minus X is the production cost. But we are given on that particular day the production cost was rupees 750. Therefore, we equate this product to 750. That is 55x minus x square is equal to 750. When you reduce it, you get x square minus 55x plus 750 is equal to 0. Therefore, this situation is represented by this quadratic equation. Example 2. Check whether the following are quadratic equations. X minus 2 whole square plus 1 is equal to 2x plus 3. You remember the formula a minus b whole square. So using that, I expand x minus 2 whole square. Then I get x square minus 4x plus 4 plus 1. That is the left hand side, which is equal to x square minus 4x plus 5. Right hand side is 2x minus 3. Therefore, I equate left hand side and right hand side. I get x square minus 6x plus 8 is equal to 0. So this is of the form ax square plus bx plus c is equal to 0. Therefore, it is a quadratic equation, no doubt at all. Now the second problem, x into x plus 1 plus 8 is equal to x plus 2 into x minus 2. So we expand left hand side separately, right hand side separately, and then we equate both. Left hand side is equal to x into x plus 1 plus 8, which is equal to x square plus x plus 8. And the right hand side is equal to x plus 2 into x minus 2. It is of the form a plus b into a minus b, which is equal to a square minus b square. Therefore, it is x square minus 4. Now we equate both of them. X square plus x plus 8 is equal to x square minus 4. Both sides we have x square. So they will get cancelled and we will be left with the x plus 12 is equal to 0. Definitely it is not a quadratic equation because x square term is missing. Here a is equal to 0. Therefore, it is not a quadratic equation. If you just look at the problem, it may seem to be a quadratic equation. So immediately you should not come to the conclusion that it is a quadratic equation. When you multiply both sides, x square are getting cancelled. Therefore, it is no longer a quadratic equation. So only after simplification, you must tell whether it is a quadratic equation or not just by inspection. Okay. Third problem. Example 2. Check whether the following are quadratic equations. Third problem. X into 2x plus 3 is equal to x square plus 1. So, we take the left hand side and expand it. We get 2x square plus 3x. We equate it to right hand side. 2x square plus 3x is equal to x square plus 1. Therefore, When you simplify, you get x square plus 3x minus 1 is equal to 0. Obviously, it is of the form ax square plus bx plus c is equal to 0. Therefore, it is a quadratic equation. Clear. Fourth sum. X plus 2 whole cube is equal to x cube minus 4. It seems to be a cubic equation, but immediately we should not come to the conclusion. As I told, we have to expand it. You remember the formula for a plus b whole cube. So I expand the left hand side first. X plus 2 whole cube is equal to x cube plus 6x square plus 12x plus 8. Because a plus b whole cube is equal to a cube plus 3a square b plus 3ab square plus b cube. I have used that formula and expanded it, and it becomes x cube plus 6x square plus 12x plus 8. Now we equate this to right hand side. So both sides we have x cube and they will be getting cancelled. So after reducing it, you get x square plus 2x plus 2 is equal to 0. Clearly it is a quadratic equation. So just if you see, it may seem to be a cubic equation, but after expanding, we get x cube term cancelled. Therefore, it is reduced to a quadratic equation only. Very good. Now exercise 4.1. Check whether the following are quadratic equations. X plus 1 whole square is equal to 2 into x minus 3. In the same way, first I expand left hand side. So it is x square plus 2x plus 1. I equate it to right hand side. So it is reduced to x square plus 7 equal to 0. Obviously, it is of the form ax square plus bx plus c equal to 0. Therefore, it is a quadratic equation. Next is second problem. X square minus 2x is equal to minus 2 into 3 minus x. So x square minus 2x is equal to minus 6 plus 2x. After expanding, I get like this. Now you bring all the terms to left hand side. So x square minus 4x plus 6 is equal to 0. Definitely it is of the form ax square plus bx plus c equal to 0. Therefore, it is a quadratic equation. These are all simple problems. Only thing you have to expand it and reduce. Third problem, x minus 2 into x plus 1 is equal to x minus 1 into x plus 3. Left hand side, I expand it. X minus 2 into x plus 1 is equal to x square minus x minus 2. And right hand side is x square plus 2x minus 3. Now I equate both. Obviously, both sides I have x square. Definitely they will get cancelled. So I am left with minus 3x plus 1 is equal to 0 or 3x minus 1 is equal to 0. Very clearly it is not a quadratic equation because x square term is missing. Therefore, it is not a quadratic equation. Fourth problem. X minus 3 into 2x plus 1 is equal to x into x plus 5. I expand left hand side. X minus 3 into 2x plus 1 is equal to 2x square minus 5x minus 3. And right hand side is x into x plus 5, which is equal to x square plus 5x. I equate both. So 2x square minus 5x minus 3 is equal to x square plus 5x. After simplification, I am left with the x square minus 10x minus 3 is equal to 0. Obviously, it is a quadratic equation, no doubt at all. Fifth problem, 2x minus 1 into x minus 3 is equal to x plus 5 into x minus 1. Similar way, left hand side I multiply, I get 2x square minus 4x plus 3. Right hand side, both factors I multiply, I get x square plus 4x minus 5. I equate both sides. I am left with the x square minus 8x plus 8 equal to 0 after simplification. Therefore, it is very well a quadratic equation. It is of the form ax square plus bx plus c equal to 0. Sixth problem. X square plus 3x plus 1 is equal to x minus 2 whole square. So there is nothing to expand left hand side. You expand right hand side, it is x minus 2 whole square, which is equal to x square minus 4x plus 4. Now I equate both sides and I am left with 7x minus 3 equal to 0 after cancelling x square. Because x square is present in both sides, so I cut out and I am left with 7x minus 3 is equal to 0. It is not at all a quadratic equation. Remember, x square term is missing. Seventh problem, x minus 2 whole cube is equal to 2x into x square minus 1. So first I expand left hand side, which is equal to x cube plus 6x square, x cube plus 6x square plus 12x plus 8, and right hand side is equal to 2x cube minus 2x. I equate both sides. So I am left with the x cube minus 6x square minus 14x minus 8 is equal to 0. So x cube term is present. Therefore, it is not of the form ax square plus bx plus c equal to 0. Therefore, it is not a quadratic equation. Eighth problem, x cube minus 4x square minus x plus 1 is equal to x minus 2 whole cube. So there is nothing to expand in left hand side. I expand right hand side, which is equal to x minus 2 whole cube, which is x cube minus 6x square plus 12x minus 8. I equate both sides. So I am left with it 2x square minus 13x plus 9 after cutting out x cube. Therefore, it is of the form ax square plus bx plus c equal to 0. Therefore, it represents a quadratic equation. Second problem, represent the following situations in the form of a quadratic equations. First sum, the area of a rectangular plot is 528 meters square. The length of the plot in meters is 1 more than twice of its breadth. We need to find the length and the breadth of the plot. A similar problem we solved in example. So, in a similar way, I take x as the breadth of the plot. So, automatically the length should be 2x plus 1 because it is 1 meter more than twice of its breadth. So, twice of its breadth is 2x, 1 meter more, therefore it is 2x plus 1. Now, the diagram. Similar diagram, x is the breadth, 2x plus 1 is the length, therefore area of the rectangle is x into 2x plus 1, but we are given area is equal to 528 meters square, so I equate it to 528. So 2x square plus x equal to 528, or 2x square plus x minus 528 is equal to 0. So the breadth x should satisfy the equation 2x square plus x minus 528 is equal to 0. So we represented the given situation in the form of a quadratic equation. Second problem. The product of two consecutive positive integers is 306. We need to find the integers. It is very simple. So you take x and x plus 1 are two positive consecutive integers. You remember the definition of consecutive integers. 5 and 6 are consecutive integers, 7 and 8 are consecutive integers, 13 and 14 are consecutive integers. So, if x is one number, then you can take the other number as x plus 1. Okay? So, I take x and x plus 1 as the consecutive integers. We are given their product is equal to 306. That is, x square plus x is equal to 306, or x square plus x minus 306 is equal to 0. Therefore, it is a quadratic equation. We need not solve it, just we have to represent the situation in the form of a quadratic equation. That's all. Third problem, Rohan's mother is 26 years older than him. The product of their ages in years, 3 years from now, will be 360. You would like to find Rohan's present age. So remember, we are given two information. One is Rohan's mother is 26 years older than Rohan's age. The product of their ages after 3 years will be 360. So what is to be found? Rohan's age is to be found. So we take Rohan's present age as x. Then his mother's age will be x plus 26 because we are given her age is 26 more than Rohan's age. After 3 years, their ages will be x plus 3 and x plus 26 plus 3, which is equal to x plus 29. Now we are given x plus 3 into x plus 29 equal to 360 because after 3 years, product of their ages will be 360. Therefore, x plus 3 into x plus 29 is equal to 360. So when I multiply, I get x square plus 3x plus 29x plus 87 minus 360 equal to 0. After simplification, I am left with the x square plus 32x minus 273 equal to 0. Therefore, rho and CAG x will satisfy this quadratic equation x square plus 32x minus 273 equal to 0. Fourth problem. A train travels a distance of 480 km at a uniform speed. If the speed had been 8 km per hour less, then it would have taken 3 hours more to cover the same distance. We need to find the speed of the train. Read the problem carefully. A train travels a distance of 480 km. So, total distance is given 480 km. If the speed of the train is reduced by 8 km, it will take 3 hours more to cover the distance of 480 km. So we need to find the speed of the train. So we take x as the speed of the train. The uniform speed of the train is x km per hour. So what is time? The hours taken to cover the distance of 480 km is equal to distance divided by speed. You remember the formula, distance divided by speed is equal to time, or the total hours taken to cover the distance. So 480 divided by x. Now we are given if the speed is reduced by 8 km, then it becomes x minus 8. In that case, the time taken will be 480 divided by x minus 8, which is 3 hours more. Therefore, when 3 is added, it is equal to 480 by x. So, after simplification, we get 480x plus 3x into x minus 8 minus 480 into x minus 8 is equal to 0. You have to carefully consider this equation. If the speed is reduced by 8 km, then it is 480 divided by x minus 8. It is the time taken after reduction of speed. But it takes 3 hours more. Therefore, 480 divided by x minus 8 plus 3 is equal to 480 divided by x. Okay. Now, after simplification, we get x square minus 8x plus 1280 is equal to 0.